Today we're going to continue talking about solving systems of equations, but with a different method called substitution. So the idea with substitution is we're going to look at the two equations that we're working with, and we're going to solve for a variable, either x or y. And then we're going to take whatever that's equal to and substitute it into the other equation. And so when I'm looking at the two equations I have to work with in this first example, I can see that x is by itself right here. So that looks like it would be a pretty easy one to use. So I'm going to go ahead and subtract 9 from both sides and just get x by itself. And then I'm going to take what x is equal to, this whole entire thing, and substitute it for the x in the second equation. And so that's going to give me 2y plus 2 times this whole thing. And then I'm going to go ahead and distribute this too. Combine like terms. And solve. Keep in mind that when you have a system of equations, the solution is an ordered pair. So what we have so far is the y value of that ordered pair. I'm going to go ahead and take this original equation up here to get our x value. So I'm going to substitute the y value that I got. It's always a good idea to use the original equation when you're finding out what the other value is. So I have 6 equals x plus 9, subtract 9. So it looks like our x value is going to be -3. And so our solution, we're going to put this in an ordered pair. The x value comes first. And so let's say I were to solve each of these for y and graph it and look at the graph. This point right here, -3, 2, that would be the intersection point. So here's another type of example. This one has to do with a quadratic and a linear function. Excuse me. And so again, I'm looking at this first equation and it looks like it'd be easier to solve for x. And that's really kind of the only time you would want to use substitution, is when you have something that it's easier to solve for x than it is for y. Otherwise, you can just solve for y and do it the other way we talked about. So I'm going to solve for x over here. So I have x equals y squared plus 2. That's the entire thing that I'm going to substitute for this x over here. So I have 2 times y squared plus 2 distribute the 2. Combine, actually nothing to combine here, but what I'm going to do is bring everything over to one side so I can set it equal to 0. So I have 2y squared minus 4y equals 0. And so now I'm going to go ahead and factor, which all of you are pros at now, I'm sure. So I'm going to go ahead and factor out the greatest common factor, which is 2y, and I'm left with y minus 2. So I'm going to have two different y values here, and hopefully that would make sense to you. If you can picture the graph of a quadratic equation, which is a parabola, and the graph of a line, linear equation, which is a line, you could in fact get two intersection points. So I have 2y equals 0 and y minus 2 equals 0. So y equals 0, y equals 2. This is not an ordered pair. These are two individual y values in which we have to find the corresponding x values to. And so you can do that two different ways. You can substitute it into this equation, or this equation. So I guess not two different ways, but you just have a few different options. I'm going to choose our first equation here. So this is to find the x values that go along with the two y values that we found. So always start with the original equation. I'm going to take y equals 0 first. So I have x minus 2 equals 0 squared, which is 0. So add 2 to both sides. And x equals 2. Really important to note when you're putting this together as an ordered pair, what y value you were doing it with. So this one along with the y value of 0. So the first ordered pair for the solution is 2, 0. And then the second one, I'm going to go ahead and do this again. Start with the original equation. Substitute the y value of 2 this time. So x equals 6, and that went along with the y value of 2. So the ordered pair for that one is 6, 2. Okay, and you can go ahead and put it in a solution set. Number 3 is yours to try. Really try it, okay? And then here's number 4. So this winds up being, these are both quadratic functions, but if I were to look at this graph, this is a parabola that opens up. And if I were to look at this graph, this is actually a parabola that opens sideways, and we're not necessarily going to get into graphing those, but this is another way where substitution is useful. So I'm going to take, this is already set equal to y, so I'm going to take what y is equal to and substitute it for this y right here. And so what I'm going to have is x squared equals 27x. And just remember, when you raise a power to a power, you're going to multiply those. So this becomes x to the 4th equals 27x. I'm going to bring this to the other side. And I'm going to go ahead and factor out the greatest common factor of x. And I'm going to set each of these factors equal to 0. That could have been a little straighter. So x equals 0, and x cubed minus 27 equals 0. I'm going to add 27 to both sides because 27 is a perfect cube. And so I can just go ahead and take the cube root of both sides to get my answer. So I'm going to take the cubed root of x cubed and the cubed root of 27, and that's going to give me x equals 3. Check it out on your calculator if you don't believe me. So x equals 0 and x equals 3. Let me scroll up to see what my original equations were, because I need to get the corresponding y values. So I'm going to start with y equals x squared. I'm going to start with the x value of 0, so y equals 0 squared, which is 0. So the ordered pair there is 0, 0. And then I'm going to go ahead and put in the other x value, which was 3. So y equals 3 squared, which is 9. So the ordered pair there would be 3, 9. So that's the solution. Again, not a bad idea to check this out. And the way you would check it is to take each ordered pair and substitute into both equations. So I would take 0, 0, for example, substitute into the first equation, see if it checks out, substitute into the second equation, see if that checks out, and then do the same for the second ordered pair. All right, so we will talk about this more tomorrow.